we will now look at different kinds of multi-core architectures. And in fact, we will start with the very first computer. You may wonder, how could it possibly affect you to learn anything about how parallel computers were developed? Well, if you don't know the history, you cannot predict the future, is common wisdom. And in particular for parallel architectures, the most fancy ideas have already been tried, and many of them have failed, and it's important to see why they have failed, and that there is no really easy way to create parallel software that can be run efficiently. There are numerous problems with different architectures, which make it quite difficult. But you shouldn't see this as a problem, but instead as an opportunity. Okay, so the goal is for you to make it easier to determine which new parallel machines will be around in 10 to 20 years or more. And don't trust anybody who says they have made a breakthrough which will make it easy to write parallel software that is fast, because that's not so easy, except for trivial programs. But let's first look at some computer generations. We will not go into the details, but just some important steps. Okay, you can pause and read this if you want to, but the interesting thing is number 5. When we start create modern parallel machines which are actually still around after more than 2 or 3 decades. I mean the ideas with them. Previously there were many experiments which cost huge amounts of money and failed often. But let's start with the first computer. And there was a person, Konrad Zuse. He was born 1910. And he was a civil engineer and found that it's really boring to be that. I don't know why, but he said so in his book. And then he thought it would be much more interesting to design aircrafts. Unfortunately for him, it was not so exciting that either. It meant doing numerous manual calculations, and he thought that was really boring as well. So he started to dream and about having a machine which could do the calculations for him. And he filed a patent for a computer in 1936, and with friends he built it in his parents' apartment in Berlin. He got pieces for the machine from friends at the telecommunications company, things which were regarded as crap and thrown away, and they could use that to build, continue building the machine. Okay, now some amazing specifications for this machine. First, it had a binary floating point. It had representation for not a number and for infinity. It had a clock frequency of 5.3 Hertz. It took almost a second to do an add, 3 seconds to do a multiplication. It had 64 words, each with 22 bits, and it consumed 4 kilowatts. And its weight was 1,000 kilogram approximately. Okay, and it worked from 1941 to 1943 when it was bombed. Okay, after the war, SUSE sold his patents to IBM to fund his computer company, and that company was successful, and there is a replica of the bombed Zeta 3 at the Deutsche Museum in Munich, and there are also original machines by Pascal and Leibniz. This is a very recommended museum, so if you go to Munich on some October, do visit that museum. It is not only a story of successes, it's also about engineering dreams and failures. So it's really fascinating to see. According to SUSE, IBM didn't understand the coming computer revolution, and they wanted his patents for other things. Anyway, his company produced approximately 250 machines, and that's a huge number considering the cost of each machine at that time. Okay, what is interesting to LTH, I mean Lund University, for those who are not from Sweden, is that Professor Lars Philipson invited Konrad Zuse to give a talk at the 5-year anniversary of the computer science and computer engineering program, the D program. And Konrad Zuse accepted, so the inventor of the computer accepted to talk to engineering students at LTH. Unfortunately, he couldn't come because he was not well at the time. He passed away in 1995. So this is the machine.